Hi everyone, this is Suresh. I'm a student at Levis University. At present, I'm taking course like robotics. In this subject, my final project is a robot path planning algorithm. In this presentation, we discuss about this project. Yeah, this is the slide of introduction, and our primary goal is to thoroughly and accurately investigate the field of reinforcement learning algorithm in order to prepare the mobile robots for the global path planning assignment with a Python programming. A fully complete RL algorithm has been achieved, and the global function is updated iteratively using QL learn technique. These slides gives information about the project objectives, and the principal aim of this project is to investigate solutions for the complex issues associated with autonomous robot navigation. Another crucial goal of this project is to include a feature in the algorithm that will allow the robot to avoid obstacles. The factor that are prioritized to establish other goals includes trajectory optimizations, safety assurance, and navigation in time. These are the main objectives in my project, and this is the slide. This slide gives information about the lectures reviews and the basis of this project, which help with the planning of the robot part and reinforcement learning algorithm is the review of peer research. The difficulties posed by the dynamic environment in front of this algorithm planning were clarified by earlier discussions. The lectures also illustrate how important reinforcement learning is to science of robots. This slide gives information about the implementation of algorithm, and robot path planning algorithms are planned using a QLearn based technique that optimize the trajectory to allow for obstacle avoidance. The implementation is divided into two phases, which are described below. The first one is QLearn framework, and second one is environmental construction. This slide gives information about the environmental setup, and it includes a calculation file that is used to conduct studies pre-training to the algorithm performance. When developing the experiment, a number of hurdles are incorporated to conduct with real-time simulation settings. The performance metrics for scaling purpose are Q-value convergence, path length optimization, and success rate ignores the obstacles. These are the main environmental setup for my project. These slides gives information about the implementation of my project. The following list contains the three elements needed to implement the QLearn based method. The environment.py classes facilitate with the environment class, while the calculation.py helps to support experiment, and the main.py class creates an entry point for performing the Q learning algorithms. These are the main three .py files to implement my project. This slides is a screenshot of calculation.py. Here we show the all the calculations of calculations of my project, and the calculation.py assist in supporting experiments. And these slide shows information about the main.py. It is a screenshot, and main.py mainly creates an entry point for executing QLearn algorithm. This is the main.py screenshot, and this screenshot gives information about the environment.py. Environment.py facilitate with a class called environment, and all the informations are provided in the screenshot about the environment.py. And this slide gives information about the scenarios. Every project have some scenarios like that. My project also has some scenarios, like the robot route algorithm that was built has undergone extensive testing and critical assessment. Various environment with varying obstacle configurations were tested using this method, and from a spacer to denser obstacles, the arrangement has changed. This slides gives information about the result of path length optimization, and path length have been seen to be significantly reduced. The system demonstrated the ability to identify the optical route through an interact settings. While all of the phenomena was occurring, the distance decreased. These are the main path length optimizations. And this slide gives information about the result of competition time. It demonstrates that excellent efficiency that makes near instantaneous path calculation possible, and it features have demonstrated that it applicable to practical situations. And finally, both timely navigation and robot safety is possible. These are the result of time computation of time. This slide gives information about the result of obstacle avoidance. This demonstrated how to escape a rigid obstruction by rerouting the device to avoid colliding with it, and its environment with the dynamic obstacles have been discovered to have a high degree of adaptation, and every time there was a change, a great degree of response was seen against every impediment. These are the results of obstacle avoidance. And this slide gives information about the result of safety assurance, and it is clear from the safety mechanism of development algorithm that collisions are prevented. It has been demonstrated that the robot will stay secure during the navigation process. Its efficiency and safety concern are skillful matched. And here are some results of timely navigation. And it has been observed that the algorithm has been built to consequently navigate inside the allotted time, and the robot movement is efficiently coordinated between the speed and perception. For time sensitive functionalities, it can be considered an efficient option. These are the main results of timely navigation of my project. And this slide gives information about the result of adaptability. An exceptional degree of flexibility has been observed in the algorithm design. During the navigation procedure, in the various surroundings, there was no deviation. It supported the algorithm versatilely and provided support for its practical implementation. These are some results of adaptability in my project. This slide gives information about the final outcome of our project, and it has three diagrams. First diagram shows the graphical one, and second diagram gives a path, starting position of the robot and destination of the robot, and final diagram gives information about the path of the robot from starting position to destination position. This is the final outcome screenshot of my project. And this slide gives information about the conclusion of my project. Promising outcomes has been observed in a robot path planning algorithm that is based on Q learning, and the study effectively applied concept from reinforcement learning and robot path planning to varying settings. This is the conclusion of my project. And the next slide is references. As I said earlier, said that I have taken some references from lectures and some of the professors' presses and university presses and some papers, and I overcome all the obstacles presented in these lectures and in these presses and these university presses. And finally, I completed my project with the overcomes of these problems in these references. And thank you so much for giving this opportunity.